Hi everyone. So today we'll be solving a LeetCode hard problem, minimum replacements to sort the array. Let's go through the problem statement once. We are given an array nums and we can perform various operations on the array. So in one single operation, we can replace like any element with any two elements which has the sum to it. So for example, here if we wanted to replace 9, we can replace it with 1 8, 2 7, 3 6 and so on, such that the sum of these two values still remain 9 only. Okay, so this is the kind of operation that we are allowed to do, and we need to find out the minimum number of operations to make the array sorted. Okay, so we need to means satisfy this condition after applying minimum number of operations. So in this case, for example, we had 393. So since 9 is greater than 3, hence we need to break it. So if we break it further into 3 6 3 3, so we have utilized one operation. Now again this 6 is greater than 3, so again we split this 6 into 3 3 and then 3 3. So this was the split here, and here the split was 6 and 3. So and again we have used one operation, so 1 plus 1 equals to 2. So in two operations now the array is sorted, so hence the output here is 2. If we take a look at another example, for example here we had 10 12 5. So if we there are multiple ways to make it sorted. So for example, if we have break this 12 to means 5 7. Now again we break it into 5 2 2 5 5, and then we can make in this break this 10 to 8 2, then 6 2, then 4 2 and 2 2. So as you can see, like there are multiple ways to do this, and we want to do it in a manner such that the number of operations required is minimum. So like and also the constraints are of the order of 1e5. So we cannot means for this kind of operation there does not exist any brute force approach, like trying all the possibilities kind of thing does not exist here. So we all means we need to make some observations and like try to see. So generally in these kind of problems we try to see the element which we will not be changing. For example, the element which will remain the same even after means applying the operation on that particular element is not appropriate. For example, here in this case, if we break the last element, like if we try to break this last element into two subparts, then this will only create a problem for us, because the new values will be smaller, and then we'll need to perform further splits for the previous values, because this value has become smaller. So for example, if the last value was 8 and initially it was 6, so if we further split it into 4 4, then we also need to split this value, right? So splitting the last value is means we will not split the last value in any case. So that gives us an idea that we will not be applying the operation on the last element. So now if the last element is fixed, for example, if last element is fixed here, so if last element is fixed, then we can try to move from the back direction and keep satisfying the sorted condition. So for example, we'll break this into some subparts, and then this will be modified. The smallest element will be modified. So for example, uh, we have an array, and this is the current element we are at. Okay, and this was the last element. So now if uh, current is greater than last, then we need to break it into subparts. So suppose we break it into K1, K2, K3 and so on, Km. Okay. Now if we break these into break this into M subparts, this should satisfy like is less than equals to last. All right, and this condition should also be satisfied, like this value should be greater than equals to. Now the value previous, which is before that, this should also satisfy this condition after we will apply some operations on pref. So we'll try to make sure that this k1, the smallest element that we get after splitting this current, is as large as possible, right? Because if it is as large as possible, then we'll need, maybe we do not need to perform any operations on the previous element, right? And since we need to minimize the number of operations, we'll try to make this k1 as large as possible. So this is means the approach that we'll try to follow greedily. So like we will start from the end. uh, just I am just trying to make observations and try to derive the results, like how we can split. So now current was greater than last. So suppose current was 9 and last was 3. So what are the possible ways of splitting? So maybe we can split it into like multiple values, like suppose 1 1 1 1 1 1 9 times, right? Or 1, then 2 2 2 2 4 times. Okay, means there are multiple ways, right? Or we can do like if we do 2 here then 7, so 3 4, right? But this 4 will not be feasible, so we not need to further break it down. So this is not possible, so like 2 2 2 3, maybe we can do this. But as we can see, like splitting it into uh, a lot of values will decrease the smallest value that we get. And if this value is decreased, then for previous elements maybe the priv will become greater, and if it becomes greater, then we will need to apply new operations on this priv element as well. So what would be the most optimal way of splitting? So as you can see, we'll try to like uniformly break the element so that the last element that we get is as large as possible. So here in this case, we'll try to uniformly break it, so it can be like 3 3 3. Like suppose for example we had 10 and 3. So now how we'll try to make break it? We'll not break it into 1 3 3 3 because this has reduced the last element that we got. We'll try to reduce it into as uniformly as possible. So we'll need 2 2 then 3 3. Okay. So what observation we can make here is, will the smallest element that we will get after dividing an element into multiple subparts, we need to make it as large as possible, and the largest value would be, for example, if current, like uh, if we are at index I and index I plus 1. So if nums of I is divisible by nums of I plus 1, then if it is divisible, for example in the case of 9 3 or 12 3, or so for example 16 4, then we will be just making it equals to num of I plus 1, right? So make nums of I same as nums of I plus 1, because this will be the most uniform way. And operations would be now means for splitting 9 into 3 threes, you'll first do it into 6 3 and then 3 3. So the number of operations is basically nums of I divided by nums of I plus 1 minus 1 in this case, right? Because 9 by 3 is 3, and the number of operations we need is 3 minus 1 equals to 2. All right. So this was the case of nums of I percent nums of I plus 1, means if it is 0. So if it is divisible, then this was the case. Now what is the case when it is not divisible, right? So nums of I percent nums of I plus 1 is not equals to 0. What do we do in this case? So we'll try to like observe by taking multiple examples. So for example, suppose we had 11 and 4. So what will be the smallest value that we can get? So for example, if I try to take 11 by 4, 11 by 4 is 2. Okay. So maybe we try to split it into two numbers. So two numbers would be 4, 4 and then 3. Okay. So maybe this, but uh, the smallest split that we will get is the seal of 11 by 4. Okay, 3. For example, if we have 10 and 4, so seal of 10 comma 4 is 3. So hence the split would be 3 3 4. Right? So to make it most uniform, in this case we will be taking the seal value. In the when the case where it was divisible, we were just taking the remainder with nums of I plus 1 and um, subtracting it by 1, and here we are taking the seal value. So nums of I would become what? Nums of I divided by the seal value of nums of I divided by nums of I plus 1. Right? So you can see for multiple examples as well. For example, it was 14 by 5. So 14 by 5's seal value is 3. So we will split it into 3 values, and 3 it is 4. So minimum value would be 4, 5, 5. Right? For example, it was suppose 18 and 7. So 18 by 7's seal value is 3. Now 18 by 3 is 6. So most uniform distribution is 666. Why we are trying to do this is the main goal was to make this last value as large as possible. As large as possible. So hence greedily we will iterate from the end, and we'll means find out the current operations. Then we will update nums of I, and so that nums of I minus 1 sees the new value that we have created. Right? So this is the approach. I hope you get the approach, like why we are starting from the end, because it is not feasible to break the last element into its subparts, because that would only increase the number of operations. And once we have that idea, we know that we'll need to start from the end, and yeah, so we just need to simply satisfy the conditions. So let's see the code for this problem. So we are declaring a variable to store the result, and we are starting from the second last element, so that now if the nums of I is greater than nums of I plus 1, nums of I is greater than nums of I plus 1, so there were two cases. This is the first case where they were, for example, 9 comma 3. This was the case of this. So here the mul variable stores 9 by 3 equals to 3, but the operations were mul minus 1. Okay, because to split 9 into 3 3 3, we only need two operations. So we will increase the nums, and we'll make nums of I as 3 only. So now the array would be 3 3, means we'll just updating the value instead of splitting it into multiple parts. So this was the case of this, and if it is not divisible, then for example it was 10 comma 4. If it was not divisible, then we are uh, dividing nums of I with mul plus 1, what we discussed, the seal value. So we will be dividing 10 by 10 with the seal value of 10 by 4, which is mul plus 1 here, which is 3. So here we will get 3. Hence nums of I will become 3, and it will become 3 4. Alright, split would be 3 4 4. Sorry, 3 3 4. Okay, and the number of operations required would be 10 by 4 only. For example, 10 by 4 equals to 2. So from 10 we move to 6 comma 4, and then from 6 we move to 3 3. So number of operations required were 2. So this was just a simple observation based problem where we just needed to find out the means. Generally in these kind of problems the main idea is to see if applying operation on any element is not is feasible or not. If it is not feasible, for example, suppose applying operation on the first element was not feasible, then we would have started iterating from the start only and then tried to satisfy the condition. So in that way, we can approach these problems. Let's try to submit it as well. So uh, yeah. So as we can see, it beats 100% of the runtime. So if you have any queries, feel free to comment down. And yeah, thanks for watching.